This is a big problem. We're going to have to propose a synthesis to make this compound into this compound. And the first thing that I always wanted to do is count carbons. So I have 1, 2, 3, 4, 5, 6 carbons on the left. And when I finish the reaction, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. So we know we have to add 3 carbons to the chain. I have an alcohol at the very end. It's now added, it's still an alcohol, but now it's 1 carbon farther away and I have 2 methyls in there. This is a secondary alcohol, which that one is kind of easy because if we reduce this ketone, we're going to get the secondary alcohol. So the first thing we need to do is just see to extending the chain by 3 carbons. So I'm going to have to take this up here and I'm going to react it with thionyl chloride, SOCl2. And that's going to substitute this OH for a chloride. That would be the easiest way to do it. It's not going to do anything to the carbonyl at all. But now I want to actually get a Grignard right here so that I can extend the number of carbons in the chain. And the Grignards and carbonyls, they don't go together. So I have to hide the carbonyl, which is what we call the protection of the carbonyl. And when you protect a group, you protect it as an acetal. I'm going to use ethylene glycol. And I'm going to use a little bit of acid, tosic acid if you will. But I am hiding, I'm protecting the carbonyl so that when I make the Grignard on the right side, it won't go and attack the carbonyl. All right, I'm ready to make the Grignard. I am going to take this and I'm going to throw in some magnesium turnings. THF would be a good solvent for this. You always go with ether solvents for this type of reactions. And what I'm going to do is that I'm going to form the Grignard on this side. My ketone is still protected. It's still the acetal. Nothing has happened to it. But now I have a really good nucleophile on the other side. So this carbon right here is the nucleophile. And I'm ready to extend the chain by 3 carbons. And whenever you actually have an alcohol like this, it probably came from a ketone or an aldehyde. In this case, I have 2 more carbons, so it came from a ketone. So what am I going to do? I am going to react this with acetone. 2-propanone. The Grignard is going to go and attack the carbon of the acetone. It's going to get you a tetrahedral intermediate. So I'm extending, I'm attacking this carbon, which is not this one. It's going to have 2 methyls off of it, and it's going to be an alcohol. And first you actually do that reaction, and then you quench the reaction, you work up the reaction. And during this acidic workup, I deprotect my carbonyl. All right, I already have 9 carbons in here. I have my alcohol, and now I have to get rid of this carbonyl. You want to go with lithium aluminum hydride or sodium borohydride. It's a ketone. Both of them will do it, but to tell you the truth, sodium borohydride, it's easier to use than lithium aluminum hydride. So if you have a ketone or an aldehyde, sodium borohydride will be way easier to do it. So notice that this simple synthesis started by first counting how many carbons we needed to add, and then making our nucleophiles and protecting the groups that we don't want to reduce yet. And then at the very end, make sure that you have all the carbons in there and that you have all the reagents that you need.